Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Muhammad Faisal Adnan and I will be showing you how our team uses the tool Innoslate to handle requirement storage and change management for our project, which is Academic Advising Management Systems AAMS. So let's look at the first sub question for project requirement storing. How does the tool allow you to store functional, quality, and constraint requirement? To answer this, in our tool Innoslate, requirements are stored in relational database entities. So to understand them, first we will go to document section. Then we can click on any item in our documents here. So let's try looking at section 1.1.1. Here we have four column of two requirements for this document. Click on any requirement. You can look at the labels. There is a drop down list of options to choose. This is where we categorize our data. So a requirement is either of these three categories: functional, quality, or constraint. But how do we know if a requirement is between these three? First, we need to know what is these three. So the first rule is this: the system's functional requirement is what it does. The rule is that it describes an action, a behavior, or specific task, then the system must perform. If you can physically click a button to do it, then it's functional. For example, a requirement description says the system shall allow a student to view their CGPA. So then it is a functional requirement. Next is a quality requirement is how well the system does it. So that the rule basically says that it defines the user's experience, performance, reliability, or speed. It doesn't add a new feature, and it dictates how good the existing features are. Then it must be a quality requirement. For example, a requirement description says like the profile screen shall load within 3 seconds. This is exactly a quality requirement. Then we have when the constraint should be the rules we must follow. So the rules that these are these designs limits or legal boundaries or technical environments imposed on from the outside, then you don't have a choice to how to build it. Then this must be a constraint requirement. For example, maybe the system must use the university's single sign-on SSO, which is exactly again an example of constraint requirement, because here you are not allowed to invent your own login systems, and they have put a constraint here. Now for the next question, does the tool follow any standard requirement template? Yes, it does. When we create a requirement in our workspace, Innoslate forces us to use a standard layout. Instead of letting us type some random paragraphs, the tool gives us three specific text boxes to fill out, which is name, description, and rationale. The name box is where we put our unique tracking ID like AMSF-FR-001. The description box is where we write the actual system rule using words like shall or must, while the rationale box is where we explain the reasons why we need this requirement. By keeping everything inside this fixed template, the tool helps us to our project follow an official engineering standards, making our document clean, organized, and super easy to grade. So now when we look at the second question for manage changes, as you can see, for manage changes, you can see a dashboard here. It has an activity feed. So this shows who made the changes, when it was made, and what part did the admin change. For example, here is 1.1.1 AMS-CR-002. We can see what was the change. Like here in this description of the requirement, there's typo. So one of our admin, which is Amri, changed the rational from O to 2. So that's it. This is all from me, and we'll move to our next member.
Assalamualaikum. So right now I will continue for the second part of our assignment, which is this. documentation, traceability, and validation. So first we will look at documentation and we will try to answer the second question first. So the question is what format is supported for this tool? So if you want to know that, we will go to our project Innoslate and we will go to database. Okay, here in the database, as you can see, it is this list is entity or class that is our requirements for this project, and currently it is listed by numbers, or you can sort it by name. So number is the easiest to see, and it is listed from lowest to highest. See the top is 1.0 and the down one is 7.2. So next, if you can see this report button on the top, when you press it, it will give you a multiple option to choose for that download. So let's say that we choose this one, basic tabular output CSV. So it will give you this another multiple option to choose. So that is okay. The include one is not mandatory, but this give you the data for your requirements. Yes, uh, data for your requirements. And currently it is sorted by numbers. So we choose numbers or class or number. So let's say number lah, because it is easy to see and file name. Let's say we use this test 4 and then we hit create. And then it will automatically download and we try to see. So right now I accidentally set this download to open with notepad. So as you can see here, it is already show the ID, the class, number, name, and the description. As you can see, this is the ID. Let's say the artifact 1.0 5704751. So it is the same, and it is also called artifact or requirement. And then the number 1.0, 1.1. Okay, it is sorted. Okay, when you download, it will automatically give you this data of ID, class, number, name, and description. But you can adjust and add more that you want by just try to download it again and add another option, which is let's say labels or created by, and hit number and then another test 5 and then hit create, and then it will download. And you can see the difference. It will give you ID, class, number, description, and then it will add another one, labels and created by. You can see the difference. Description and then labels and created by. So this is labels as for requirement document. Let's go back to the first question, which is how does the tool support requirement specification? Okay, so in all the traditional software management projects, team will use static files like Microsoft Word to write down their requirements. So the massive problem with this is that if a stakeholder wants a constant changes, uh, admin will end up with multiple documents file. This will make the project administration incredibly confused about which one is the latest update because of a lot of multiple file. So to solve this problem, some teams try to use cloud options like Google Docs because user can edit simultaneously and they can see the revision history, meaning that they can see what changes do people make and when do they make. But you still have a double workload because you still have to manually transfer that flat text from the Google Docs back into the separate development or like this living a database project. So Innoslate solve this fundamentally by treating our document as a living specification project, meaning that one stakeholder enter the data directly into the live project repository by clicking new requirement, which is this is what I just made, and by creating our requirement, see, untuk requirement, to, and then it's safe, or they want to make some changes within the description text box or rationale. There is no file duplication or manual copying. So if you can see in the database or in the dashboard, we can see here in the activity feed, which is what we just do. I just did this about 4 minutes ago, and this is what we did 1 second ago, few seconds ago, which is it shows us who made this, which is me. When this when does I make this, and what did I make, which is I just created uh, in the document 9.2 test 2, and I added new requirement, which is 9.2 requirement 2. So by running our CSV report, which is this the database, the tools take this live database data and instantly produce, meaning they take the latest update that happens in this project. So it requires internet, so it will constantly save any data that we do. So let's say I just create the new requirement, and if I hit import and try to download, so whenever I open, it will constantly add the new 9.2 requirement. So supposedly this need to have something which is the description. So since we didn't have anything, so it will not show any. And now let's move into the next question, which is traceability. So if you want to see the traceability, first we need to navigate to the database, and then as you can see on the top right here, beside the reports, we see the metrics button. So inside here, what we're gonna do is we will choose uh, query as our top x-axis, then it will gives us another box of text, which is query. So let's say we will type here class statement. So if you will hit enter, it will does nothing. But if you choose the, let's say, connected to, it will show something like this. So on the top left bias filter, we have our query, and then see on the top right, uh, the rows running on the left down here display our lower level system requirement, and the top right here is our connected requirements that share an engineering dependency. So as you can see on the grid, our requirement 1.2.1, where 1.1.2 or any automatically connects to our other system requirement across the top row. It connects to everything. So this proves the immense value of using a live database tool. If an engineer wants to modify a requirement text box in the document view or update a role parameter, so this intersecting links stay active and update live in real time. So these relational architectures completely prevents messy conflicts, protect our project from hidden scope creep, and visually proves that our academic advising management system requirements are perfectly connected and integrated with each other. That is all from us. Thank you.